Hello, this video is on solving systems by substitution. Um, so we'll be solving these systems of equations, and generally you're going to want to isolate one variable, either x or y, and then we're going to plug that equality back into the second equation. And you generally want to look for an x or a y with no coefficient, like say this x, but with if they all had coefficients, it's as simple as dividing off by one of those coefficients. But we'll worry about that later. So let's take a look at these systems of equations. Okay, so I'm going to punch these into my my little screen here so we can work on it. Let's see, what do we have? 9x minus 6y equals 3, and the second equation is minus 3y equals 7 minus x. Okay, so we're going to solve this. So I said the first step is to isolate one of the variables. And we can isolate this x pretty easily. It's a negative, so I always like to add it to the other side. So let's work with this here. We'll get x minus 3y equals 7. And then add 3y to both sides. X equals 3y plus 7. Okay. So what can we do with x equals 3y plus 7? Well, you can literally just plug it into x here. So x is equal to 3y plus 7. So you can see this is the second equation. We literally just plug it in for x. You see what we did there? We had x equals 3y plus 7. So we do, 3y plus 7. That's it. And then we have one equation with one unknown, right? So we can leave the other equation. Oh, actually, we'll leave this for now. Okay, so now we have to solve for y, and that's actually something we know how to do, and that's pretty easy. So let's say, well, 9 times 3 is 27y plus 9 times 7 is 63. And then we do minus 6y equals 3. And well, if we combine the like terms here, well, minus 6y, that's minus 6, so 21y plus 63 equals 3. And then if we subtract 63 from both sides, well, we'll get minus 63, which would be minus 60. Is that right? And then y equals, so what does y equal? Y equals negative 60 over 21. Y equals, right? We just divided each side by 20. And I think these each have a common factor. So we can say 21 is 3 times 7. And then 60, well, that's 6 times 10, or 3 times 2 times 10. So the 3's cancel out. And we're left with negative 20 over 7. So y equals negative 20 over 7. And it's kind of ugly fraction, I know, but we'll just work with it. And then we already have an equation where x equals 3y plus 7, and we know what y is. So again, you know, this is the equation from the second equation, but we already solved for x. So just put in negative 20 over 7 plus 7. So again, this is kind of ugly. What do we get? Well, we'll get 60 on the top with this 3. So what do we get? Negative 60 over 7. Negative 60 over 7. And then 7 over 7 is going to be, well, 7 squared. What is that? 7 times 5 is 45 plus 14 is 15, 40. Wait, yeah, 49, right? I thought that was right. 49 over 7. And again, you know, I'm just guessing all my arithmetic here, but if you're ever not sure, do 7 times 7 is 49. What did we do before that I wasn't sure about? I don't know. So 9 times 3, 27. So I encourage you to check all your work on a calculator. That way you'll make sure it's right. Okay. Anyway, so okay, maybe I'll keep that calculator open so I can do negative 60 plus 49 is 11, minus 11, right? So this comes out to minus 11 over 7. Okay, so our x is minus 11 over 7, and our y is negative 20 over 7. So now let's take a peek at the answer, correct answer. Yeah, so that's what it was, negative 11 over 7 and negative 20 over 7, right? So again, to recap, we looked for the x, which had no coefficient. We turned it into this lovely equation right here. There. 3y plus 7. And then we plugged it into the first equation, right? And then we solved for y, and we got negative 20 over 7, and then we solved for x, and we got negative 11 over 7. And that, if you follow those steps, that should be it for solving the system by substitution.